Today we are going to learn about energy recovery ventilation, and we're going to look at the energy recovery ventilator in our building at 231 Main Street in New Paltz, which is a zero energy LEED platinum building. We're going to go up in the attic, which is underneath the conditioned enclosure. The roof is fully insulated and airtight. So the mechanical equipment is inside the conditioned enclosure. Then we're going to look at the energy recovery ventilator, open it up, and I'll explain how it works. This is the energy recovery ventilator for this building. I'm just going to shut it off. This one's fairly large. It's 5,400 square feet of useful area. The building is actually energy modeled at 8,100 square feet. In a house, you might have a much smaller one. Some buildings may have many or several of these. We've done a big project where there's an ERV that's as big as a small truck, so they vary in size, but the principles are basically the same. Inside the machine, there are these coils. In this case, they're made of plastic, and they're just a series of many small tubes, and you can take a closer look later. What happens is, the way this is set up is the machine sucks stale air from the bathrooms, the kitchenette, and the basement. It brings it up and brings it through the machine, through here, and diagonally through the coils, and blows it out that side of the building. It brings fresh air in from this wall down through these coils into this duct, which then distributes it to the two air handlers in the building, which then circulates fresh air around the building. So what happens is the stale air is brought through, it crosses the fresh air that's brought through. All these little tubes are right next to each other. They're not connected, but they're adjacent to each other, so the tubes conduct the energy, either the heat or the cool from the cooling season, from the stale air into the fresh air as they pass each other in these tubes. And so it recovers about 70 to 80% of the energy. Some are even more efficient. So come and take a close look at these tubes just to get a sense of what they look like. So you can see all of these little tubes that are bringing the fresh air in. You can actually feel cool air here coming in. And so the fresh air is going through these tubes, and they're immediately adjacent to the stale air tubes, which are here inside this, what we call a coil. Took these filters out as we were going. These filters filter, say, dust and dirt from the fresh air that's coming in, as well as from the building, from the stale air. And they get, in this building, they get changed twice a year. So, and that's on top of the filters that are in the air handlers. So we like double filter the fresh air and the air in the building, in addition to providing the ventilation air. All ERVs or HRVs have some form of filter, and all air handlers have some form of filter as well. This is the air handler over here, just as an example. So this services, in our case, just the top floor of the building. And so it's bringing return air from the various rooms and providing conditioned air to all of the rooms. In the process, it's also providing fresh air from the ERV. And most of the conditioning in this building is done with air source, high efficiency air source heat pumps. And currently it's set when the outside temperature is 5 degrees, this natural gas furnace will kick on if we need heat. So we use a minuscule amount of heat in this building. I mean, a minuscule amount of gas, I should say. It's almost all electric. Electric bill is $30.62 a month, every month.